All right, intersection means parts that overlap. This is the warm-up that we should have given to you today. So A intersection B, the intersection is where they overlap in between. Okay, A intersection B prime. So let's think about that for a second. This means anywhere inside here is B, anywhere outside is B prime. So the intersection of A and B prime is out here. Now let's think about that for a second. I've just colored in a space that was inside A, and I've colored in a space that's not in B. The prime means not inside B. Okay, now this says not in A and union with B. So anywhere not, so now this is union, right? So not inside A not inside A and union with B. So B is everything in this region right here, right? So anything that's colored in general is what A prime union B would be. Let's look at the next one. A union B prime. So A and union B prime. So anything outside of B. Okay. Next one. A intersection B. A intersection B would be just this part right here, like we did over here, A intersection B. But prime means anything except that. So I'm going to shade only outside of this region. Why are we shading everything except inside the football looking region? Because of the prime. It means anything except that. Okay. A union B prime. So A union B would be inside these three regions. So prime means we're going to shade anything except those spaces. Okay, now let's do the questions that you saw in class. So is rolling a die and tossing a coin independent? If I toss a die and flip a coin, is the process of rolling the die and the process of turning the coin going to affect one or the other? And the answer is no, they don't affect the other, so they are independent, yes. Because this value does not affect how the coin is going to fall on the paper. So the probability of rolling a 1 and getting heads. So this probability is going to be equal to, so rolling a 1, I have a 1 out of 6 chance of rolling a 1 on the die, and probability of getting heads, I've got a 50-50 chance. So multiply those together, and we have a 1 out of 12 chance. Okay, so the formula for independence is the probability of A intersection B is equal to the probability of A times the probability of B. And we're going to be using this relationship a lot in today's activity. So what is the formula for the law of probability? So you can get it off of your formula packet, but what we have learned is that the union, so the probability of A union B is equal to the probability of A plus the probability of B but as you can see, the way I've shaded it, I've counted this football region twice because the yellow region was A, the blue region is B, and we've counted this middle part twice. What is that middle part called? A intersection B. So we need to subtract the value of A intersection B once. That was supposed to be green. Okay. So what does this look like? This looks like the probability of A plus the probability of B minus the probability of A intersection B. You might want to pause and think about that for a second. We had to subtract this because we counted this overlap region twice. Okay, next part. Okay, so what does this mean? Okay, the line here means the probability of B given A. So the word given means we are only looking inside A. So I'm just going to shade all the part that doesn't matter. Okay? So everything that's in blue is not in our world. Okay, we're only looking inside the white circle space. Okay? So if we're only looking there, what is the probability of getting B? So B is this yellow region right there inside A. So how this works is this yellow region, as we said before, is the intersection, right? So, and I'm going to have the probability of B intersection A divided by what is the probability of this white region? It's probability of A. Okay, and we're going to be using this relationship a lot. So the probability of B given A is equal to the probability of the intersection divided by the probability of whatever it is that we're trying to whatever is given. So if we're given this probability of A, then then we're going to have it like this. Now the probability of getting A given B, what we're going to do is we're going to have in this, okay, given B, that means it has to be inside this space here. So again, the unshaded region has to be in there, and we want the probability of being in circle A, which is this yellow region. So once again, my numerator is equal to the intersection of A and B, once again, right? And my denominator here is the probability of B. Okay. Okay, Lastly, now this part we didn't do in our notes, but we probably should have. So, if A and B are independent events, then the occurrence of each other doesn't affect the probability of the other. So, explain why the probability of A given B is equal to the probability of B given B prime is the probability of A. So, basically what this means, if events are independent, then it doesn't matter if about the then the occurrence of B doesn't affect. Okay, so if the event are independent, then the occurrence of B is not going to affect the probability of A. So, for example, if I'm tossing a coin, given that I had a 2, or given that I didn't get a 2, whatever this dice is not going to affect the fact that I still got a heads. So this probability of getting A the given B or not given B is not going to affect the probability of getting A. You might want to hit pause and rethink this and watch it if you need help again. You can watch it as many times as you want.